Hello friends, welcome back to Breath of X program, Insight Fellowship program in Advanced Analytical Problem Solving Expertise. And we are in the middle of Six Sigma Green Belt certification. That's the first module of first certification under Advanced Analytical Problem Solving Expertise of X program. Right? I'm Santosh Avsarkar. And let's recap what we did in a previous video. We started with capability analysis. And in nutshell, capability analysis is nothing but, it helps us to understand whether our performance or whether performance of given process or given metric is within client given specification range, specification limits. If it is client given specification range or limit, then next is performance on the target every single time, or at least most of the time. These two questions get solved through capability analysis. So we were at capability analysis. We started it, we're almost at the middle of capability analysis. In the current video, let's go ahead into part 2 of capability analysis. So let's go to next slide. Next slide, please. Right, so this is where we left capability analysis, in last video, right? So scale of Six Sigma, the maximum value is 6, minimum is not 0, but less than -1, right? So when Sigma score is less than -1, what it indicates? It indicates that your metric performance is quite poor, because quite rarely metric is performing within client given specifications. And there is a huge number of or high number of non-compliances. Secondly, quite rarely your performance is on the target. So if the performance of a given metric is like this, if the performance of the given process is like this, what are we going to expect? We are going to expect our client will fly to the competitors. So if the performance is consistently in the range of 0 to -1 for that matter, right, or less than -1, this is the prediction, or we can predict it quite easily, that our clients will not sustain with us for longer period of time. They will just fly to some other competitors. Now, if client going to fly to some other competitors, of course, we're going to lose the business. So sigma value or capability is also an indicator of the survival of the company, or it is a predictor of the survival of the company, if I may use this word. Right? So every single time, every single company, at least once in a month, need to test the capability of the given process. And if the process do have different number of metrics, for every single metric, they need to ensure or they need to check where the given metric is standing. This is very, very important, because there is no point, after losing client, will start crying that, I lost a client to the competitions. No, we are not going to lose clients to the competition. No company loses clients to the competition. They loses client to their poor performances. And sigma score, or for that matter, capability, is an indicator that indicate poor performances quite early. And that is the power of capability analysis. I shouldn't be giving this example, but again, unfortunate example, but yes, that's a very important example. We cannot cure cancer, but we cannot cure cancer at stage 3 or stage 4. What if we get to know about cancer in stage 1? There is a possibility that we can help that individual survive. Right? So the point over here is, when are we going to know about the cancer? When are we going to diagnose the cancer? If we're going to diagnose it lately, we're going to lose that individual, because by that time, chances of survival will be quite less. So we have to diagnose cancer quite early. The same thing, this is kind of a cancer of the organization, and capability is that diagnostic tool which help us diagnose the cancer of the company quite early in the stage. If consistently a performance or sigma value is below 0 or close to 0, we have to work on it right away. If we will not, we are going to be nowhere. So that's about -1. The sigma score of 0, what it indicates. Sometimes, not every time, but sometimes the metric performance is within client specification, but there is a huge number or high number of non-compliances. And again, we are quite rarely meeting the target of the given metric. That's what 0 indicates. Then comes to the score of 3. Metric performance is within client specifications most of the times with many visible non-compliances. But good part is at least frequently we are on the target, not rarely. Frequently we are on target. Most of the companies globally, they do have a set standards, and that is why most of the companies do stand over here, here or here in this range. But if you want to beat the competition, you've got to be to the right side, I would say, of this number 3. So you got to be close to 4. If you are reaching 4, you got to reach to 4.5. If you're reaching to 4.5, you have to think about how you can reach to 5 and ultimately 6, which is the ideal state. And what 6 indicates? 6 indicates metric performance is within client specification every single time with absolutely no non-compliances. And it also indicates performance is almost on the target every single time. If not every single time, most of the time. This is the ideal state. So if you're standing over here, you have to strive to reach to this number of 6, this magic number of 6. If you're standing over here, you have to at least try to reach to this number. Then from here to here, 3, that is from 0 to 3, and from 3 to 6. Likewise, every single company should strive to improve the performances across the metrics if they really want to survive and grow. And capability analysis helps us understand where are we standing, and it can help us predict the future of the organization. That's the power of capability analysis. So let's go to the next slide, please. Well, over last few slides, we understood the process capability. But now let's understand the process capability with some pictorial representations. So let's go to next slide. Right. So imagine there is a boat rowing competition, and there we are having 4 different players over here, or kind of four different teams over here. Team 1 with relatively larger sized boat, and then team 4 is relatively smaller sized boat. They need to row in the given lanes. These are the lanes given to them, and size of the lane is almost same for all, not almost, same for all, right? Now they have started the race into their own lane. What is going to happen? You'll find that within first minute itself, this team will either hit to this side of the lane or this side of the lane, and that will be foul, and they'll be thrown out of the competition because of that larger size of the boat. However, this boat with a relatively smallest possible size of the boat, they are rowing quite swiftly and easily, and if you could observe it, they are rowing it in the middle of the given lane, so chances are quite less that they can hit either of these two sides. So they can very easily and swiftly row. So whom you think is going to win the competition? This player is already out of the competition. So rest of these 3, who's going to win, right? Definitely this player is going to win that competition because A, the size of the boat is quite small, and B, they are rowing in the middle of their lane. So risk or chances of they crossing their lanes is relatively smaller. So they can very easily and swiftly row. And that is why this team is going to win. So this situation is nothing but Six Sigma situation. And this situation is nothing but -1 or less than -1 situation. So with less than -1 situation, what is going to happen? Very easily, we'll be able to understand. Now let's translate this example into business scenario. These are the four different players, right? The size of the boat is nothing but variation in the performances. And all four players do have a same specification limits, that is the lane given to them. Now, if size of the boat for a given company, which is nothing but the variation in the performance is quite high, then they can or they will cross the specification limits given by the clients. Clients will be unhappy, and this company is going to lose to the competition, and this company will be out of the competition. But this company, when the variation of the performance is low, then what is going to happen? A, the performance is always going to be in the client given specification, and they'll try to middle it, means they try to be on the target. So when you're going to be on the target with your performance, and if you're performing within client given specification, of course, when you're performing on the target, you're always going to perform within client given specification. So there's two conditions. Condition one, your performance is within client given specification and your performance is on the target. When this is going to happen, you can very easily, smoothly, and swiftly grow into your business. And you can be a champion in your business. And that is what Six Sigma indicates. This is the example what we have. So size of the boat is nothing but variation in performance causing non-compliance, and distance between that rowing lane is nothing but client given specification. That is the value of Six Sigma. When your company is standing at Six Sigma, if not Six Sigma, near to Six Sigma, beyond 4, be assured, beyond this number of 4, be assured that you are going to be quite ahead to the competition. And that is the indication of long time survival for you in a given business. That is what capability analysis is going to assess for you every single month. So ideally, every single month, company needs to do this assessment for all the processes and all the metrics for that matter. That's the power of capability analysis. On that note, let's go to the next slide. Right. So we talked about Sigma score, which is nothing but an indicator, or in other words, a metric to assess capability of the given process or given metric. Right. So a key deliverable of measure phase is a measurement of baseline, that is as its state capability performance. So if you could remember, while going through the objectives of the measure phase, we mentioned that measure phase help us understand how deep is the problem. That is, it helps us measure the current as its state, a baseline. All three words indicate the same thing, right? Current or baseline or as its state capability performance. That's what we do with the help of capability assessment in measure phase, which is nothing but our fifth and a final step into measure phase. How are we going to do that? A, we are going to do this with calculating Sigma score, and B, we are going to do it by calculating defect per million opportunities, or which is also called parts per million opportunities. So parts per million, PPM. So PPM is more or less quite familiar word in the industry. So parts means defective parts, per million means per million parts produced. So when you're going to read parts per million is nothing but defective parts produced per million parts produced. So that is the PPM. So these two indicators or metric, parts per million and sigma value, is going to help us find out our current state's capability for a given process or for a given project Y. So let's go to the next slide and understand it. It's very, very easier mathematical equation to calculate this, ppm or sigma values. So it's not like a rocket science or not even advanced mathematics. It's like a 8 and 9 standard mathematics. So it's quite easy to understand. So first thing, all we need to do is find out what are the total number of units we worked upon. So units here in our case would be total number of ships we calculated, or sorry, we captured or collected the data. So what is that number? Total number of ships we capture the data, that is N. Then total number of defective ships. So how many ships are not meeting client given specifications, or is nothing but total number of defectives. So that will be indicated by K. The next thing is proportion defectives, which is nothing but PD, is a ratio of K divided by N, K by N. Once we find K by N, all we need to do is multiply K by N by 1 million, which is nothing but 10 lakh. In Indian terms, we call it 10 lakhs, right? So PD, that is K by N into 10 lakhs, will give us parts per million. Simple. It's 8 to 9, not even 8 and 9 standards mathematics, even 5th and 6th standard mathematics. So that's it, all you need to do over here. This is how we're going to calculate ppm, which is the indicator of capability. Second way, sigma score, which we talked about a lot. How are we going to calculate sigma value? Easiest possible way is provided by spreadsheet. All we're going to do is just put the formula of is equal to norms in V in bracket 1 minus PD. K by N is PD, so 1 minus PD. Norms is equal to norms in V in bracket 1 minus PD will give us sigma value, a current sigma value of the process. So let's go to next slide and understand it. It's very, very, very easy. So total number of ships, we captured some data in a major phase, right? So we captured it for say 90 days, sorry, 30 days. So 30 days means 30. Each day we do have 3 ships. So total number of ships for which we calculate or we capture the data or collected the data are 30 into 3, 90. So our N is 90. Total number of defective ships. Ships which consumes average processing time per unit more than 270 ships. How many ships are there? In currently collected data in a major phase, 35 ships. We have 35 ships over here with total number of defectives 35, where all these 35 ships do have average processing time per unit more than 230 seconds, which is beyond client given specifications. So how we are going to calculate PD 35 by 90, which is nothing but 38.89. How are we going to calculate parts per million? PD into 10 lakhs, not 1 lakh. It's 10 lakhs. So PD into 10 lakhs is 3,88,888.89. In other words, all it indicates is here, based on a major phase data, we can conclude that 3,88,888.89 number of ships are defective ships had we collected data for 10 lakh ships. So 3,88,888.89 is the value of parts per million, which is also quite high. And how we are going to calculate sigma value? Sigma value is nothing but the formula is equal to norms in V in bracket 1 minus 38.89. When you going to calculate this, spreadsheet will give us the value of 0.2822. Thank God it is not less than -1. It is also not less than 0, but it is close to 0. There is a huge possibility or huge scope for improvement. When our sigma score is standing at 0.2822, it means most of the times our performance is not within client given specifications. We do have higher number of non-compliances. This is higher number of non-compliances. And of course, most of the times our performance is not on the target, and we have to find out why we do have these number of defectives. We need to work on it, right? So we need to improve. Maybe we cannot jump from 0.28 to 1 or 2, right? We have to go from 0.2822 to 0.5 to 0.8, then 1, and likewise we keep on continually improving the performance. But one thing is sure, we have to improve the performance from this state. If we will not, if the given process or given project will not improve, client will be dissatisfied on this metric, and client may leave you for that matter. Client may fly to some other competitors. So that is why this is very important aspect. Now all we're going to do is we will just shift ourselves to spreadsheet, and we'll try to take a couple of examples. How are we going to calculate parts per million and sigma value? It's very easy, but let's take a live example and do it together, right? So let's go to MS Excel or spreadsheet. Right. So we are in a spreadsheet. Let's take a small example over here, right? So the total number of shifts, we capture. The data are like say here. Let me do this. Total number of shifts. Or say this is random example, right? 75 shifts for that one, right? And total number of defectives. 75 which were not meeting the client given specification. This is random example. This is not for that processing time non-compliance metric. We're not talking about that metric. Just a random case we are taking. Right. So total number of defectives. Say total number of defectives are 37. It's an odd number, right? So now this is what is my in. This is what is my key. So how I'm going to calculate proportion defective, which is nothing but K divided by N. So here is equal to 37 divided by 75, which will give me 0.493333 is my PD. Now, how am I going to calculate ppm, that is parts per million? How am I going to calculate it? I'm going to calculate it with PD to 1 million, that is 1,000,000, 6 times 0, right? So all I'm going to do is I'm going to click over here is equal to this value to 1,000,000, that is 1 million, is equal to 4,93,333.33 is my parts per million. Now let's go ahead and calculate sigma value. How am I going to calculate sigma value? Formula is norms in V in bracket 1 minus this PD. This is K by N is PD, 1 minus PD. So how am I going to do this? Thanks to the spreadsheet for bringing this formula in the picture. So is equal to, I'm going to, while calculating, while using any formula, I need to start with is equal to norms in V, NOR, RM. I could see norms in V here. Norms in V, right? NORM, norms ENV, norms in V. All I'm going to do is what? 1 minus K by N, that is PD, this value. And I'm going to complete the bracket. Is 0.0167. This is what my sigma value. Yes, this is little higher than 0, but it's almost 0. It got to be improved. This is example number 1. Let's take another example. Let's consider the same example of PT non-compliance, right? So total number of ships were how many? N. Those were like 90 ships, right? 30 days data what we collected for a major phase. 30 into 3 ships per day, 90 ships. Total number of defectives, that is those ships which do have average processing time more than 270 seconds, right? So I'm just going to put it more than 270 seconds over here because we all know that. So 270 seconds. How many were there? This is K. So those were like 35, right? 35. So what is my PD? PD is equal to K by N, which is nothing but is equal to, because I'm going to use the formula, that's why I start with is equal to 35 divided by 90. 0.3888. Just take an example. If I'll not use is equal to, what is going to happen? 35. So I'm going to calculate. So I'll put this value. Yeah, I'm not going to get it over here, right? I need to have is equal to 35 divided by 90. 0.3888, right? The same thing, right? So that, I mean, I'm just showing why we need to use that is equal to sign. Right, now parts per million. Parts per million. How am I going to calculate it? PD into 1 million, that is 10 lakhs. 1,000,000, 6 times 0. So is equal to PD is this value to 10 lakhs, that is 1 million. 1,000,000. Enter. The value is 3,88,888.8889. That is my parts per million. That's one of my capability indicator. Second is sigma value. So how am I going to calculate sigma value? Just like this. I'm going to copy it over here, paste here. Now I'm going to use the formula. Is equal to, let me do it again, is equal to norms in V. So I need to go over here. Norms, NORMS, INV. Norms in V is equal to, in bracket, 1 minus the value of K by N, that is value of PD, which, and bracket complete. I need to complete the bracket. Equal to 0.2822. That's what we got it. So this is about how we are going to calculate parts per million and sigma value. This is our first indicator of capability. This is our second indicator of capability. So first indicator and second indicator. This is example 1 and this is example number 2. This is how we are going to calculate parts per million and sigma value. This is that simple. So I guess on this note, I'm sure you all have understood it. So please do practice it at your end, and you'll be very easily able to find out what is the sigma value and how can you calculate sigma value in parts per million. It's not a rocket science, right? So on that note, let's get back to our presentation. This is what we were, right? 0.2822. So let's go to next slide. Right, here's time. In Six Sigma, capability is indicated or calculated by, let me read it again. In Six Sigma, capability is calculated by two options, parts per million, ppm, and second, sigma value. So which is right? Only parts per million or only sigma value or both parts per million and sigma value? The answer is both parts per million and sigma value. So in Six Sigma, we calculate capability with the help of parts per million, that is ppm, and sigma value both. So on that note, congratulations to all of us. We have successfully completed first two phases of Six Sigma, define and measure. In upcoming video, we are going to enter into analyze phase, where Do you remember we had X's? We somehow in this phase of data collection, here we can see data collection. We had Y as well as critical X's, right? So now we need to figure out, what are the, out of those critical X's, which X's are statistically significant. So we need to further prioritize those critical X's into statistically significant X's. So statistically prioritize significant few causes from critical many causes. That's what we're going to do into analyze phase, of course, with the help of tests like chi-square test and goodness of fit test. So on that particular note, I guess we're almost done with our this video. We're almost done with the major phase as well. So in our next upcoming video, we will definitely get into our analyze phase. So as we kept on requesting you, please help us reach out to your friends, family, relatives, and the network and neighbors. Please let them know. When I'm saying please help us reach out means please let them know that we are coming up with the initiative of breath affix and how it is going to be helpful to them as well. Because we have to ensure that we contribute in nation building. On that note, Uttishta Bharata, Ma Bharati shall rise again in her full glory. Before we end, let's thank our let's thank companies who are really helping us, to be very honest, unknowingly with their technological support. So we deeply appreciate following technology companies for their technological support. These are the companies. If you like our today's video, please press that like button. Please share it with your friends and families and relatives. And of course, if you are not subscribed to our YouTube channel of Break Effects, please subscribe it. So on that note, thank you so very much for your time and have a wonderful, wonderful time ahead. And let's meet up again into our next video into analyze phase. Thank you so very much.